And welcome to Systems of Confusion with Eric Henry and the OB Algebra 2s. Here we go. Oh, that's pretty cool. But this is what we're here for. Let's do some systems. I'm going to go through each of the skills and concepts here and then solve each of the problems. I highly recommend that you try to do each of the problems on your own first before watching the video. So systems, what are they? Well, the skills that you need to have by the end of this unit are you need to be able to solve systems of linear equations in two variables by graphing. What does that mean? That means that you can think of a system of linear equations and you can recognize that each of the equations represents the equation of a line, solve it for y, and use slope-intercept or other techniques to graph the line, and recognize that the solution to the system will be the point of intersection of the lines. That point is on all the lines, and so is therefore a solution to each of the equations. Solve 2x2 systems of linear equations by using substitution. So now we know that we have two equations. We know they're linear equations, and we want to solve them with substitution. Again, solve the first equation, or the second, for one of the two variables, and plug in the expression to the other equation, solve, and plug into either of the original equations to find the value of the second variable. 2x2 systems using elimination. Here you multiply or divide the equations to get the coefficients to line up or to be opposite, and then you either subtract or add respectively to eliminate one of the variables, solve the resulting equation for the remaining variable, and plug in to find the second variable. Graph linear inequalities on a number line, including absolute value inequalities. Here we've got a number line, and you're going to have a linear inequality. So I want you to be able to graph that accurately. So take things like x greater than or equal to 3, and recognize on a number line that we have 3 here, a solid dot shaded to the right. Graph 2x2 systems of linear inequalities. Here we can take two inequalities, y less than or equal to 2x plus 5, and other inequalities, and graph them on a coordinate plane, and recognize the solution to the system of inequalities as the points which are shaded and which satisfy both of the inequalities. Simplify and work with functions in two variables. Functions in two variables, things like this, f of x comma y, recognizing that if you, well, that's a weird half 2, half 3, 2x plus 5, y plus 7, that if you have a function written like this and you have f of 3 comma 2, 3 comma 2, what you do is you plug the 3 in for the x, the 2 in for the y, and simplify to get your value of the function in two variables. Approximate, find the exact solution to linear programming problems. This is when you have an equation like this, along with a system of inequalities. You graph the inequalities, you plug the points in the intersecting, in the bounding region into the function, and determine the highest valued point. Approximate solutions to any single valued equation using a graphing calculator. This is all about the graphing calculator unit that we worked on, mini unit that we worked on. Being able to take an equation that looks like 2x plus 3y equals 5x, single variable, so no y's. 2x plus 3 equals 5x plus 7, and recognize that what you can do is put into your calculator y1 equals that, and y2 equals that. Treat it like a system, and find the point of intersection. And that point of intersection will have an x and a y value, such that if you plug in the x value, you get the same y value as if you plug in here for this y value. And so this expression will equal this expression. And it will solve the original equation. Adjust the window settings of a graphing calculator effectively. We spent a lot of time working on this. It's the stretching and squishing a pan full of caramels idea. Practice makes perfect. You need to try graphing lots of complicated equations. Go back and look at those worksheets, and feel free to ask for help. I'm happy to show you how to do any of those problems. Find the approximate relative minimum maximum, zeros and intersection points on a graph using a graphing calculator. Here we've got minima, maxima, zeros, and intersection points in the second calculate menu. You have the options to do this. For each of those, zero, minimum, or maximum, and intersectional. Three of those, all four of those options are in the calculate menu when you hit the second button and then the trace key on your calculator. Left bound, right bound, all of that stuff. Make sure you practice that. Model real-world problems involving up to 3 quantities and up to 3 constraints with a system of equations. Use algebraic techniques and or geometric techniques with the aid of a graphing calculator to find the solutions to the model and interpret those solutions. This is all of those systems, word problems, Khan Academy exercises. Go back through those. Make sure you know how to solve those word problems. And we'll see a good number of those example problems like that in the coming questions down below. Optimization problems involving linear relationships by using linear programming, and interpret solutions to those linear programming problems in real-world context. The same thing as we talked about up here with linear programming, but now in real-world contexts. And we'll see some examples in here of problem scenarios like that. Again, what you do is you have to come up with the inequalities in this case, graph the inequalities, and look at the boundary points and plug those into the functions to determine which values optimize the function. Moving on to concepts. These are the concepts that we want students to gain significant familiarity with. Understand what a system of equations is. Students should be able to give a correct definition of a system and understand why the sum or difference of two equations produces a third equation that has the same solutions as the first. Understand what a system of equations is. So what's a system of equations? It's a set of equations. Could be 0 equations, 1 equation, 2 equations. Could be any number of equations with where the variables refer to shared quantities. So the x's in each of the equation refer to the same quantities. And a solution to the system is a set of values for the x and y's, for the variables in the equations that satisfy all of the equations, that when you plug into each of the equations you get a true statement. You can have 0 solutions, you could have infinitely many solutions, and you can have a single solution or 3 solutions or any number of solutions depending on the system. Understand why the sum or difference of two equations produces a third equation that has the same solutions as the first. If you remember, when we looked at this, we said we've got our left-hand side equals our right-hand side, and we've got our second left equals our second right, and we add together the equations, and we get L plus S equals R plus C. And it looks like kind of a mystery, but we realize that really what we've done is we've taken the first equation, we've added to that equation S on the left side, and when we add C on the right, it's really not a different value because we know C and S are the same thing. So we've really added S to both sides of the equation. We've added the same quantity to both sides of the equation. Okay. Understand the connection between the possible arrangements of two lines and the possible solutions to two linear equations in two variables. Possible arrangements of two lines. Possible solutions to two linear equations in two variables. So how can two lines lie? How can two linear equations? It's important to realize the correspondence between those. Whenever you have two linear equations, you have two lines. And what are the possibilities with those? And we saw that you can have the two lines can represent the same line. So really you don't have two lines, and really you don't have two equations. There are two equations that are equivalent to each other. So every point on that line is a solution to that system, right? That's one of the two cases. The other case that we talked about is you have parallel lines and there's no point that lies on both of the lines, or you can have two lines that intersect, and then the point that lies on the line is a solution to both of the equations. Okay, understand why the maximum and minimum of a linear programming problem must occur at the vertices of the feasible region. This one is a bit of a stretch. I'm going to mark this as that's extension, that's extra. I think it's a really interesting case. I have a whole separate video on this, and if you're interested, ask me and I'll cover it, but I've decided that we're not going to cover that particular concept in class. Understand that if a continuous function takes positive and negative values over an interval, then it must take the value of 0 at some point in that interval. So if you've got a continuous function where at some point it's negative and at some other point it's positive, what has to happen between that positive and negative point? If you can draw it without picking your pencil up, well, at some point between those, no matter what happens, it has to cross the x-axis. And what does that correspond to? That corresponds to a 0. That's the strategy that we used on the calculator to find zeros. We gave it a point that was negative and a point that was positive, and the calculator could hem in the 0 point. Okay, understand how a graphing calculator works and be able to apply that understanding to adjusting the window settings effectively and to finding zeros, relative minima, maxima, and intersection points. Okay, where were we? Quick interruption for the family. Understand how a graphing calculator works. And be able to apply that understanding to adjusting window settings effectively, finding zeros, relative minima and maxima, and intersection points. What is the graphing calculator doing? It's making an XY table and plotting points. It does it really quickly, but that's all it's doing. XY table, plotting points, understanding that can help you to understand how to think about and use the zeros, the minima and maxima, and the intersection points. Okay, time for some calculations. Problem number 1. I'm going to try to hold myself to 5 minutes at most for each of these problems. A few minutes explaining and a minute or so solving the problem. Jacob bought 2 types of pens. Blue pens that cost 60 cents each, red pens that cost D times as much as the blue pen. If the cost of 3 blue pens and 6 red pens was $10.80, what's the value of D? So whenever I do a problem like this, I read it fast through like that, and I have a feeling at the end like, oh my gosh, I don't even know what's going on. I almost always have that feeling. What I'm doing right now is I'm reading back through it, and I'm thinking about what variables are at play. and I'm thinking about how I could represent these variables. And this sentence here keys me in that the cost of the blue pens and the cost of the red pens is important. So I'm going to add some variables. They might prove to be a little redundant, but I'm going to add them just to be able to think about this problem a little more easily. So C is going to be the cost of blue pens. I don't know, let's do B actually. Cost of blue pen, one blue pen, and R is the cost of one red pen. Okay, and now we can see if we can write some equations using these quantities. We know that blue pens cost 60 cents each, so we know that B is equal to 60 cents. We know that red pens cost D times as much as blue pens. Very easy to write this equation wrong. Very easy. I don't even know which way to write the equation right now. What I do is I immediately utilize this and create the value that the red pens would have to be, and then I use that to write the equation. So red pens cost D times as much as a blue pen. So if D was 3, let's say, if D is 3, what would I do to 60 cents to get the cost? I'd multiply by 60 cents. And that would give me R. So that tells me that R has to be 3, or in this case, D times B. Or we already know B is equal to 60 cents, so I can write R equals 0.6 D, rearranging. So I have an expression for R, I know the value of B, and I can now look at this sentence here that's telling me a relationship. This was is basically an is, it's an equals sign. So I have this equality here. The cost of 3 blue pens and 6 red pens. Well, if one blue pen is 60 cents, 3 of them is going to be 3 times that. And if one red pen is 0.6 D, then 6 of them is going to be 6 times that. And it equals 1080. And I can now solve this equation to find, I notice that the only variable left in the equation is D, and I can solve this to find my value. 1.8 plus 6 times 0.6, 6 times 6 tenths is 36 tenths, or 3.6D equals 10.8. Subtract 1.8 from both sides, 3.6D equals 9. And divide by 3.6. To get (9 over 3.6). And panic for a minute, because that seems like a surprising value for D. Maybe we have an error. That's 90 over 36, which simplifies to 45 over 18. 3 goes into both of those. 15 over 6. And 3 still goes into them. 5 halves. Okay, so that seems a little less frightening. 250. 2.5, not 250. 2.5 times as much. What is the value of D? 2.5. That seems plausible. I am going to check the answer key just in case. Wouldn't want to go through the whole video and have it wrong. Something I recommend doing as soon as you do the problem, check to see did you get it right. And at the end, we see that it is in fact correct, 2.5. Okay, second problem. George took a non-stop flight from Dallas to LA. Dallas to LA. Total flight distance of 1,233 miles. Plane flew at a speed of 460 miles per hour for the first 75 minutes of the flight, speed of 439 miles per hour for the remainder of the flight. To the nearest minute, how many minutes did the plane fly at a speed of 439 miles per hour? Okay, so I read that whole problem really quickly, and what I was trying to get was just a feel for the problem. Now I'm going to read it over, kind of trying to put myself into George's situation. He flew from Dallas to LA. So we've got this flight, Dallas to LA. On this flight, the total distance is 1,233 miles. The plane flew at one speed for the first portion of the flight and a different speed for the other portion, the remainder of the flight. So there's some point between Dallas and LA where the plane slowed down from 460, it switched from 460 to 439. And if we knew where that point was, well, then we could just figure out how far it was from that point to LA and how long it took to get there. And we could get our answer for how many minutes the plane flew at that speed. How many minutes did the plane fly at that speed? There we go. Okay, I was confused there for a minute, and I realized that we can get our answer, but I had to think through it. And let me see if I can make my thinking explicit. I was considering whether I could adjust this number here without breaking things. And whether I was actually going to use that number in my calculation. And I realized that that if I changed that number, it would change the amount of remaining distance after the first portion of the flight. So that's what I'm going to start with, is figure out what this distance is. The first distance. That's the quantity that I first want to know. And so I know that if you fly 460 miles per hour for 75 minutes, 460 miles per hour I know that if I multiplied by hours, if I multiplied, for instance, by 2 hours, I would get just as an example, 2 hours, I would get the miles flown, right? And that would be 920. But I don't have 2 hours. Instead of 2 hours here, I have 75 minutes. Okay, well, let's try that. Let's write down 75 minutes and see what we get. 75 minutes. Now, what's the problem? Well, minutes and hours aren't going to count when I'm doing my unit analysis here. So what am I going to have to do? Well, I need to change those minutes into hours. And how can I do that? Well, I know how many minutes there are in an hour. I know that in 60 minutes, there is 1 hour. And so I could multiply here. Now, is that going to help me out? I have minutes in the numerator here, minutes in the numerator here. When I multiply those, it's not going to give me the hours, right? It's going to give me minutes squared over hours, which is not what I want. I don't want to multiply minutes by minutes. I want to divide minutes by minutes. I want to cancel those out. I want to write those the other way around. So let's do that. Let's switch that around and make it 1 hour per 60 minutes. Now when I do my unit analysis, the minutes is going to cancel with the minutes, leaving hours. The hours can cancel with the hours, leaving miles. So I just need to multiply these numbers across. 460 times 75 over 60. And I will get this distance here, the total distance that the plane flew when it was flying at 460 miles per hour. And you could use your calculator for this. I probably would. It's a little fun to try and do it in our heads, for me at least. I know 15 goes into 64 times, and if you add one more 15 to 60, you get 75, so that's 5 15s and 4 15s. So I really have 460 times 5, right? That's 75 divided by 15 over 4. That's 60 divided by 15 miles. And 4 goes into 460 evenly. You can do it long division over here, or if you wanted to do this in your head, think of 4 goes into 400 one time and into 60 15 times. We just did that problem, so 115. But we can also just do it out. 1 times 4 is 4. Subtract, bring down our 60. 4 goes into 60. I guess 4 goes into 6 one time. 1 times 4 is 4. Subtract and get 2. Bring the 0 down. How many times is 4 going to 20? 15. And we get that same answer without the mental gymnastics, 115 miles. So we find that it that was 460 divided by 4. Yikes. We still have to multiply by 5. So let's do that. Times 5 to get our miles. We know 115 times 4 is 460. So add another 115 onto that. That's 575. So 575 miles. Now we're going to take this, we're going to subtract it from this and get this distance here. So this is 1,233 minus 575. And this is a calculator portion of the test. And just to show off the calculator, why don't we do that? I'm having fun with this. 1,233. So 1,233 minus 575. And you see, whoa, 1,233 minus 575. And you see we get 658. Lots of tricks to doing that. But that's the way I'm going to do it. So that is 658 miles. Now we can read the problem again, and we can ignore a huge portion of the problem. We don't care about this anymore. We don't care about that anymore. What we care about is that it flew at the speed of 439 miles per hour for 658 miles. So it flew at 439 miles per hour, for 658 miles. So let's try that. Let's write that down and do our unit analysis again. 439 miles per hour. And I want my answer to be in time. So I want to get this kind of hours. I want to get this into hours. And it's right now, the time is in the denominator. We have hours per minutes. But if I switch that, right, times 1 hour per minute, and that would give our miles per minute, it would still have the problem of having the hours in the denominator, right? We need to get those hours and time, get that time out of the denominator. So the way we're going to do it is we're going to divide. We're going to divide by this. That'll flip, when you have a fraction in the denominator, it flips it. So if we take something and put it in the numerator up here and divide by miles per hour, it's going to turn that miles per hour over upside down. So let's take to the nearest minute for how many minutes did the plane fly at a speed of 439 miles per hour. What did we have here? 658 miles. So we take 658 miles, divide by this, and when we flip the denominator over, we get 1 over 439. Right, that's over 1. So flip it upside down. Hours per mile. And we can cross off the miles. And then we just do 658 divided by 439. 658 divided by 439. And that gives our hours. Still not our answer. Really easy to make the mistake at this point and get the problem wrong. We don't want hours. We want minutes. They underlined it for us. So I'm going to multiply that by how many minutes in an hour? 60 minutes per 1 hour. I can cross off those hours, and I just need to multiply that. 658 over 439 times 60. 658 over 439 times 60. And we get 89.9 minutes. 89 minutes and 89 minutes. Let's see what the 89.93 minutes equals 89.93 minutes. And again, check our answer. 89.93 rounds up to 90. Oh, I probably said to the nearest minute. To the nearest minute, so we need to round that up, is approximately 90 minutes. Okay, I'm moving way too slow, everyone. We gotta pick things up. I'm getting bored. You're getting bored. Let's get through these. Number 3. Here we have a system of equations problem. There's a bunch of different ways to do this problem. Right? We know that we could graph it. We could use substitution. We could use elimination. We could go with trial and error. And try and plug these values in for x and see if they work. I don't know, that might be fast, right? 0, plugging 0 in, that's pretty fast. Y equals negative y equals negative 4. Right? When I plug 0 in, that cancels. Negative y equals negative 4 and y equals 4. Oh, we just found the answer. Right? So there's the fastest one. It wasn't even in the list of 3 of strategies, but it is a strategy that you have some familiarity with. We're going to go back and do this problem, a strategy that you're more used to. I guess we'll use elimination. It's really well set up for elimination. And you can either subtract the 2 equations or add the 2 equations. I find students add most often, so let's add. When we add, there's another reason to add. Remember, we want to get the value of x. When we add, we eliminate y because they have opposite sign. The coefficients are the same. They both have coefficients of 1, but they're opposite signs. So if we add, we eliminate the y. So we get 4x equals 0. And when we solve that, right, divide both sides by 4. 0 over 4 is just 0. You get the same answer. We don't even need to check the key for that. The functions f and g are defined by these here. For what value of x is that true? Well, I can just take and plug in to get a resulting equation. 4x minus x squared equals 4. You all have several strategies for solving equations like this. Primarily, the ones I think you're probably most familiar with, factoring and quadratic formula. I'm going to move all the terms to the right side. 0 equals x squared minus 4x plus 4. Right? I jumped the minus x squared to the right, became positive. I jumped the 4x to the right, became negative. And I have my equation. Now, x squared minus 4x equals 4. I usually, when I'm in this situation, I write it the other way. I find it easier to think about. I have that expression, and I know it equals 0. Now I want to think about how to do this. If you're good at factoring, you might see right away that negative 2 times negative 2 is 4, and negative 2 plus negative 2 is negative 4. So I could write x minus 2 times x minus 2 equals 0. The value of, we have an expression times another expression equals 0. So that tells us one of those 2 expressions has to be 0. They're only 0 when x is 2, so there's our answer, x is 2. You could also solve this using the quadratic formula. Good idea to look that up and make sure you remember the quadratic formula. Next problem. Y equals 2x plus 4. Y equals x minus 3 times x plus 2. System of equations is graphed on the xy plane. At which of the following 2 points do the graphs intersect? This is really just asking you, do you get what a system is? Do you understand what it means to be a system? Right? Remember, these two, these quantities, this y and this y, refer to the same quantity. That x and these x's here all refer to the same quantity. And if we graph the first one, we're going to get a parabola, 2x plus 4. And if we graph this one, we're going to get another parabola that looks like that. And this parabola... looks like, well, I don't quite know what it looks like. There's some tricks that I could show you to figure out what it looks like. That's not a parabola. This is a parabola that looks like this. That's y equals x minus 3 times x plus 2. This is just y equals mx plus b. So I can put in my 4 and my slope of 2. And I have the sense that they're going to intersect at that point right there. But they want to actually know where they intersect. Now, if I made this graph, and I made it carefully enough, I can see that the answer has to be A because it's the only one that's in quadrant, right? Quadrant 1, quadrant 2, quadrant 3. I can tell that this point has to be in quadrant 3, and that's the only point in quadrant 3. So I could just say the answer is A, just from thinking about it, making a quick sketch. But we're going to go through and just solve it. These equations are set up for using substitution to solve, right? I can take this value here, which is the same as that y, and I can plug it in for that y, which we already said is the same as this y here. So then I end up with 2x plus 4 equals x minus 3 times x plus 2. 2x plus 4. I'm going to FOIL this out, the first terms. I'm going to use the distributive property here to expand this expression. We haven't proved FOIL yet, and we might not this year, where I'm taking the term in front and I'm going to distribute it to the x, and then I'm going to distribute that same term to the 2, right? The distributive property says this. So I'm just doing that. In this case, this expression right here is my A, and I'm distributing it. Here's my B, here's my C, distributing it. And I get x minus 3 times x plus x minus 3 times 2. Simplifying further, I'm distributing the x here. Really, I'm moving it to the front and distributing it. We're not going to be too technical. Plus 2x minus 6. Nice. Look at that 2x and that 2x. Whenever that happens, I can subtract 2x from both sides. Get rid of them. I'm going to move this 4 over to the right. So I have 0 equals x squared minus 3x minus 10. Factoring again, negative 5 and 2. Good thing I didn't put my answer in. 0 equals x minus 5 and x plus 2. What's going to happen? What's going to happen over here if I continue my graph on? If I continue my graph on, they're going to intersect again. I almost forgot, or I did forget about that point. The math just showed me that there was an error. A is not actually correct, and x equals 5, x equals negative 2 are the two solutions. So this is not one of the solutions. Negative 3 is not the same as negative 2, but 5 is, and so one of these two solutions is going to be correct. And how do I find it out? Well, I take this x equals 5 and plug it back in. Probably want to choose this one here. So y equals 2x plus 4. Take that 5, plug it in. Y equals 10 plus 4 equals 14. And our answer is D. Number 6, during mineral formation, the same chemical compound can become different minerals depending on the temperature and pressure of the time of formation. Phase diagram is a graph that shows the conditions that are needed to form each mineral. The graph above is a portion of the phase diagram for aluminosilicates with the temperature T in degrees Celsius on the horizontal axis, and the pressure P in gigapascals on the vertical axis. Which of the following systems of inequalities best describes the region where sillimanite can form. Well, this sillimanite thing here is a big hint. Right? They want something about sillimanite. So I'm picking up on that. But I'm going to read the question again and actually read it for understanding this time. Right? The end of the question is telling me that I want to find the region where sillimanite can form, and then I want to know what system of inequalities corresponds to that region. During mineral formation, the same chemical compound can become different minerals depending on temperature and pressure at the time of formation. Okay, so depending on temperature and pressure, a mineral is going to become different things. A phase diagram is a graph that shows the conditions that are needed to form each mineral. The graph above is a portion of the phase diagram for aluminosilicates. With the temperature T in degrees in Celsius and the pressure P on the vertical axis. Which of the following where sillimanite? Okay, so I do want this region. I want to figure out what this region is. Looking at the graph, I can see that I've got a line here, and I've got another line right here, and sillimanite is all the points above that line and below that line. So if I can write the equation for both of those lines, then I can use those equations to create my system. This problem might be particularly receptive to using the answer keys, right? This 760 is an easy point to plug in. It's easy to plug in 0 for y, or 0 for what's y? Pressure, 0 for pressure. So if I put 0 for pressure, then I should get 760, and I want the values above that. I want P, I want it to be greater than, right? If I'm thinking about this one particular number line, I want everything above 760 when the temperature is 0. So if I put temperature is 0, the pressure should be above, if I put 760 for the temperature, blah, blah, blah. If I put 760 for the temperature, the pressure should be 0. Like I want all the values where the pressure is above those values, right? Pressure is above here. So if I put in T of 760, and I imagine putting 760 in here, and I think about, is P above? Well, P is above here, right? P is above here. So these are possible. Those could possibly correspond to this number line. This one could not. This one possibly could, because we got P greater than. This one possibly could, because we got P greater than. These I can eliminate right off the bat without even kind of looking at them, because there's nothing where if I plug 760 in for the temperature, I have this particular number line here corresponding to all of the pressures being greater than 0. And, so I can eliminate D. But now we're going to actually just, I don't find that. I guess if we actually plugged 760 in for these T's, we'd probably get 0 in some of them and not in others. And that would be useful and get us there. But let's just write the equation the proper way. So let's write the equation of this line. And then use that equation to do some further work. So the equation of this line, we have P equals, and I'm going to start with, we have 2 points, so I want to use point slope form of the line. point slope form of a line. And I think it's often easier to write it like this. Y minus y1 equals m times x minus x1. There we go. And so there's point slope form of the line, and in terms of p's and t's, we would have, this would be p minus p1 equals m times x minus, what? Not x, t minus t1. And we can use that 760 to get us a long way on this problem. If I put 0 in for p, if I, let's just do the slope here. y2 minus y1 over x2 minus x1 equals, what is that, 0.38, 0.38 minus 0 over 500 minus 760, which is 0.38 over negative 260. So we get our slope of 0.38 over negative 260. 0.38 over negative 260. .0015 with the negative. And, you know, so looking at this, we can probably eliminate A right away, and now we're down to choosing between B and C. But let's just continue, so we're not using the multiple choice answers, we're really just ignoring them, and get the rest of this problem. So we can plug in, let's plug in the 760 to this equation along with, our m value. So we get p minus p1 is that, p minus p1, so just equals negative 0.0015 times t minus 760. Which is equal to negative 0.0015 plus 760 times that, and 760 times whatever that number was that's still in the calculator's memory, times 760, we get 1.11. Plus 1.11. It's definitely right. And we want P above those. We want P above again. So we want P greater than or equal to negative, oh, I missed my T here. Negative 0.0015 T plus 1.11. And when I look over here, I am a little troubled by the fact that there's no equation corresponding to that. These ones right here are pretty close. I'm guessing that they whoever did this made an error and used the rounded version of that to multiply by 760. Let's double check. So 0.0015 times 760. 0.00 times 760. Oh, 0.0015 times 760. Missed a zero. 1.14, and 1.14 is still not the same as 1.13, but it's right. 1.13 is between those two, so they made some sort of a rounding error. So we determined that one of the constraint equations, the equation corresponding to this, the blue line, not the red line, the blue line, and all the space above the blue line, right? This here, this yellow region, that corresponds to this equation, which happens to be the same as that one and that one. It doesn't match this one or this one, so we can confidently cross those out, but we still have to look at the other equation now and determine which one of these two equations we'll get. So let's write the equation for this line here. We have 2 points on that line. We're using the strategy from your geometry class equation of a line through 2 points. This is what we did before, but I want to do it a little more carefully and less haphazardly. So we have the 2 points, 795, 1, and 500, let's erase that because I can't read, 500, 0.38. And so now we're going to write the equation of the line that goes through those 2 points. We're going to find our slope and use our point-slope form of the line to get that equation. M is, I'll do 1 minus 0.38, y2 minus y1 over 795 minus 500 equals 0.62 over 295. Okay, and 0.62 over 295, 0.62 over 295, and we get a value for our slope of 0.0021. 0.0021 is approximately equal to 0.0021, and looking over here, we see that only this equation has that correct slope. So the answer has to be B. We're stubborn. Let's finish the problem and write the equation now. So we have this right here, this form of the line. So I'm going to paste this down here. Not going to paste it because it keeps getting the image. I'm just going to rewrite it. P minus P1 equals M times T minus T1. And we already know what M is right here. Plug that in. And plug in one of the 2 points to find out the value. Let's use this one here because it's easier for me to draw. So we'll plug the 795 in for T1 and the 1 in for P1. And we get P minus 1 equals 0.0021 times t minus 795. Solve for p equals 0.0021 t minus 0.0021 times 795. Now, just based on the last one, make it a rounding error again, 1.67. 7, and don't forget that this one moved over, plus 1. So we have p equals 0.0021 t minus 0.66, and b is confirmed. That's a fun problem. Have some fun with that. Great opportunity with some complicated calculations, or I shouldn't say complicated, with some hairy decimals that have a bunch of digits that you need to keep track of. Calculation of an equation of a line through 2 points. So you get to do that twice. And we didn't ever look at what inequality is. We should, right? We want, when we're looking back up here, we want the values that are underneath the red line, right? We want everything underneath here because we're going for the Solomonite. So we want everything underneath the red line, where the p-value is underneath the red line. So we want to say p less than or equal to 0.0021 t minus 0.66, and that symbol does match there. So, anyways, number 7, the cost C in dollars to make n units of a certain product is given by this right here, where A and B are constants. Costs $17 to make 3 units and $62.50 to make 10 units. What is the value of B? So we have a constant here, and we know that if we plug 3 in, then we're going to get the cost to make 10 units. 3, we're going to get the cost to make, if we plug 3 in for n, then we're going to get $17 for C. So we can take this equation here, and we can use this pair of values to get a sense of what our A and our B must be. So let's try that. We plug in 3 for n and 17 for C. 17 equals A times 3 squared plus B. Well, that's 17 equals 9A plus B. And now we have the same situation, but with this other piece, this other point, this other piece of information. So we can plug 10 in for n, 10 in for n, and 62.50 for C. So 62.50, we're going to do this equation over again, but use this information. A times 10 squared plus B. And so I get 62.50 equals 100A plus B. And what do I have? Well, right here is a system of equations. So I can solve that. Set up pretty nicely for substitution. Take this B, although it's asking me for the value of B, so maybe I want to substitute the A's. Is there an easy way to substitute them? 9 and 100 is kind of annoying. I can't really I can't solve for the A or for either of the A's very easily, and I can't use elimination to eliminate the A very easily. So I'm just going to go with what's easy and solve the whole system. Get my value, do a substitution with B here. So I have B equals 17 minus 9a, just solved for a by moving the 9a to the right. And now I can take this expression, which is equal to b, and plug it in for that b right there. And now I have an equation that has only a in it. I don't care about a, but it'll help me get b. So 62.5 equals 100a minus 9a is 91a plus 17. Add or subtract 17 from both sides. 45 plus 17 is 62, but I want a half, so 45.5 equals 91a, still in the calculator section, so I'm just going to do that. You might think to yourself, 45 and a half twice, 45 and 45 is 90, a half and a half is 1, so you might just think to yourself, oh, that's 1/2. But let's do it in the calculator, 45.5 over 91. And we get 1/2. So a is 1/2. And now I want to figure out what b is. I'm going to use this equation since it's set up here for me. I'm going to take this 1/2 and plug it in for a right here. So b equals 17 minus 9 times 1/2. 9 times 1/2 is 4.5. B is 17 minus 4.5. 4.5 and 17, if I add 12 and a half, and 4, 12 and a half and 4 is 16 and a half. 4 and a half makes 17. Okay, so 12 and a half is my answer, and it's right there. Number 8. If x, y is the solution to the system of equations above such that x is less than 0 and y is greater than 0, what is the value of y? Well, here we could have, just like in that earlier problem, we could have two intersection points. We have a parabola, 2x squared plus 5, and we have a line, 2x plus 9. So that line is going to intersect twice again, once there and once there. And so we want the one where x is less than 0 and y is greater than 0. We want that point there is the one we care about. Even if you don't see that, you can just start your process of solving. Take this, plug it in for y, use substitution. So what we get, 2x plus 9 equals 2x squared plus 5. Move all the terms to the same side of the equation. Let's move them all to the right. 0 equals 2x squared minus 2x minus 4. I could try and factor this, but even faster, I'm going to notice that I have a 2, and a 4. They're all divisible by 2, so I can divide both sides by 2. 0 over 2 is just 0. 0 equals x squared minus x minus 2. Much easier to factor. But since I've done a couple factoring, why don't I remind you of the quadratic formula? It applies in this situation. X equals negative, let me move that down a little. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, b is negative 1, c is negative 2, and I plug those values in to get my x values, negative 1, negative sign, with the negative 1, negative 1, that's going to be positive 1, plus or minus the square root, b squared negative 1 squared minus 4 times 1 times C is negative 2. Notice that I put the parentheses around the negative number to make sure that I get my multiplication correct. 2 times 1. Negative times a negative is positive, so I have 1 plus or minus the square root of 1. Negative times a negative is a positive. 1 plus 4. Oh, sorry, 1 plus 8 over 2 equals 1 plus or minus root 9, or 3 over 2. 1 plus 3 is 4 over 2 is 2, or 1 minus 3 is negative 2 over 2 is negative 1. We already decided we wanted the negative, but again, x is less than 0, so negative 1 is my answer. Oh, and what is the value of y? Yikes! Negative 1 is not my answer. What is the value of y? Note that as I was ready to scroll on to the next problem, I read one last time what the question was actually asking. Very easy to do all this work and get it completely wrong, get no credit on the problem because you didn't do that, didn't catch the kind of phrasing of the problem. You need to give the y value. What is the value of y? So if we have an x value of negative 1, what's our y value? We're going to take our negative 1 for x and plug it in to find our y value. Y equals 2x plus 9. Plug negative 1 in. Y equals negative 2 plus 9. And that is 7. And our answer is 7. Okay, number 9. At a snack bar, each medium drink costs $1.85 and each large drink costs C more dollars than a medium drink. What a confusing way to phrase it. Well, because they're trying to make it fun for us. At a snack bar, each medium drink costs $1.85 and each large drink costs C more dollars than a medium drink. If 5 medium drinks and 5 large drinks cost a total of $20.50, what's the value of C? Okay, so looks like they want me to set up a system, right? And when I'm looking at this problem, that word and phrase occurs to me. I'm going to set up a system, and then I'm going to solve the system, and I'm going to get the value of C. The values that I care about, C, the things that I know is the cost of the medium drink and the cost of the large drink. Those are kind of the two quantities that are at play. So I got medium equals cost of medium. And I know what that is, 185. L equals cost of large. And I know that it's C more than medium. So whatever the cost of the medium is, C, if I add more to it, I get, if I add more to it, I get the cost of the large. What did I say? M plus C. So I can illustrate a point. Oftentimes, students put the C on the wrong side here, put the C over on the L side. Try some numbers to think about it. If the medium costs $1.85, would it make sense for the large to be less? No. So make up a number for the large. Let's say it's $2. So if we put 2 over here and 185 over here, how much more is the 2? It's 15 cents more, and we get, and the equation works. The equation checks out if it's written that way. If the C was on the other side, you'd get a negative there, and that wouldn't make any sense. It would be more than. Okay. We now have an expression for the large drink, an expression for the cost of the medium drink, and if 5 medium drinks and 5 large drinks cost a total of $20.50, well, there we go. 5 medium drinks, 5 times the cost of the medium, plus 5 times the cost of the large is $20.50. And we have expressions for both of those. M is just 185. L is 1.85 plus C. I'm missed my 5. Plugging that in for L and rewriting 5 times L, 1.85 plus C. And the way that I recognized that that was wrong is because this 185, when I looked at this and didn't, the way I knew that I was missing the 5, when I looked at the expression written without the 5, I recognized that the 185 shouldn't add only one time, right? When you're thinking about 5 large drinks, it should be the cost of the medium times 5 plus the cost of the extra of the difference between the medium and the large times 5. The 5 has to multiply by those. Okay, so anyways, I fixed it, and now I distribute 5 plus 1.85 plus 5 times 1.85. I have 5 185s and add 5 more 185s. How many 185s do I have? 10 185s. If you have 10 185s, you have 1850. Subtract 1850 from both sides. 5C equals $2. C is 2/5 of a dollar. 2/5 of a dollar. Or 4/10 of a dollar, or 40 cents. Another system of equations. Okay. We've done substitution. We've done elimination. We did checking points. We haven't actually used the calculator. Why don't we do that real quick? So this, I'm going to solve for y. Y equals negative x plus 21. This one, solve for y, negative 2y, come on now, negative 2y equals negative x minus 3. Divide both by negative 2 to get y equals 1/2 x plus 3/2. Y equals negative x plus 21. And I can graph those on the graphing calculator. And I forgot already. 1/2 x plus 3/2. I'm double checking this one too. Very frustrating to put the wrong thing into your graphing calculator. 1/2 x plus 3/2. Graph it. There's the first line. And I can't see the other line. Well, let's go back and look at it. That first one. Look at that value, that 21 there. It is way up above, way up at 21, way up here. So how do I do that? Well, I want to change my Windows settings, right? So up here, the y-intercept is way up here at 21. I want to grab up here with my hand and grab down here with my hand and squish all of this in. So I'm going to change my y max to something above 21. Let's make it 30 just to give us some extra space. So I'm going to go into Window. Y max, I'm going to change to 30. And I'm going to hit graph. And now we see that first equation and the second equation. And look, they don't meet on the graph. What do I need to do? I need to do the same thing and stretch to the right. So I'm going to change my x max now to 20. And look over there. And I have my two lines meeting right at that point. And I want to find that point. So I hit the second key and I go to calc. I find my intersect option 5. I tell it the first curve is the one going down. I hit enter for the first curve. I tell it the second curve is the one going up. I hit enter for the second curve. It asks me to guess. I take my cursor, get it as close to the intersection point as possible, and I hit enter a third time. Intersection is 13, 8. Just solve the system. Kind of a fun way to do it. What is the value of x? 13. Number 11. Oh, the one that I did with the calculator was one where I said no calculator. Don't fall for that, everyone. You've all got to do this using either substitution, elimination, or by graphing by hand. I'm not even going to make a recommendation. Have fun. And the rest of these problems, hopefully now I'll remember, the rest of these problems are without calculators. In the xy plane, point A is contained in the graph of the solution set of the system of inequalities. Which of the following could be the coordinates of point A? Okay, well, let's make a quick sketch of these to see what this system looks like. That's what they're asking us to do here. Y-intercept of 11, slope of -2. Up here at 11, slope of -2 down to right 2. Do I want above or below that? I want above. I want all of this. Okay, that's the first equation. Second equation. Let's look at the second one. Y greater than 3x minus 9. -9. Let's do this in green. -9. Slope of 3x. So let me try a better line than that. And I want everything above that line. So now I grab this thing and let me switch to the green. And I'm looking for above the green line. And the points that are shaded twice are in this region right here. That region right there. So I want those points. Which of the following could be the coordinates of point A? I need it to be up in that region. 6, 6 sure looks promising. We better get ourselves a little bit more than that, right? What can we do? We could just plug in. So I'm going to try that, just plug in. It could be that we don't want to go over that far, and we want instead like 4, 5. But either 4, 5 or 6, 6. This is really steep, and I didn't draw it steep enough. I'm going to guess it's 4, 5. Let's start with 4, 5. So we put 4, 5 into this equation. 5 greater than, checking it, 3 times 4 minus 9. Is 5 greater than 12 minus 9? It is not greater. Not greater. Let me do it this way. Not greater than 12 minus 9. 5 is not greater than 3. So this point is right out. Let's try the other one. 6 greater than 3 times 6 minus 9. Is 6 greater than 18 minus 9? 18 minus 9 is 9. It is. Okay, now we try 6, 6 in the other one. Is 6 greater than or equal to -2 times 6 plus 11? -12. Is 6 greater than or equal to -12 plus 11? It is not. So 6 is right out the window too. Uh-oh. Not looking good here. Definitely didn't draw it to scale, but let's just keep going through this set. 4, 1. So now we put 1 in for y. Let's do the bottom equation first. 1, is it greater than 3 times 4 minus 9? Is 1 greater than 12 minus 9? It is not greater. So B is out. 2, 1. Is 1 greater than 3 times 2 minus 9? 1 is greater than 6 minus 9, -3. So it satisfies the second equation. Now we plug in for the final equation. Let's write it down and then I'll slide in 1 greater than or equal to negative 2 times 2 plus 11 is 1 greater than or equal to negative 4 plus 11. 1 is not greater than or equal to 7. So none of the points satisfied. What does that tell us? It tells us don't panic at all. One of these we made a mistake on. Let's go back and see how we think about finding our mistake. I was pretty sure from our analysis at the beginning that one of these had to be correct. I was surprised to find that they weren't. So my intuition tells me maybe I made a calculation error in one of those. A very common calculation error is to either mix up the negative signs or to put the switch where the X and the Y that you put in. So, with C, I have the chance that I could have done both of those. So I'm going to check C first. So 5 is the value that should go in for Y, and 4 is the value that should go in for X. If I plug that into this equation here, I get 5 greater than 3 times 4 minus 9. 5 greater than 3. And look what I wrote right there. Oh no. Or, oh yes. It's all perspective. So much in life is like that. We just found out that C does in fact satisfy the second equation, and now we're really thinking, I bet that was our mistake, but are we moving on? No, we're taking it as an opportunity to check the first equation. 5 greater than or equal to negative 2 times 4 plus 11. 5 greater than or equal to negative 8 plus 11 is 5 greater than or equal to 3. It is. So C is our answer. And as a bonus, we got it wrong at first and found it out. Number 12. There's actually much more to say on that. I'm going to leave it unsaid. Which of the following could be the x-coordinate of a solution to the system of equations above? X-coordinate of the system of equations above. Oh my, look at all this mess. I don't want to plug those in. On the other hand, well, I don't know. I am looking and I'm seeing this and I'm saying, I think they want me to do a substitution. After the last problem, I'm going to just go with what they're pointing me at. I'm going to plug that in for y right there and get this equation right here. Or actually, this equation right here. So I'm rewriting the top equation, but instead of y, I'm putting negative 2x plus 4. Going to simplify inside the parentheses first. Negative 2x plus 1 squared equals 40. I'd love to save myself from having to expand all of these terms, but I can't see a way out of it, so I'm going to expand. It's a good chance to mention what happens when you do x plus 2 squared. You get x plus 2 times x plus 2. You do the expansion that we saw earlier today, x plus 2 times x plus x plus 2 times 2. Expand further, x squared plus 2x plus 2x, right, expanding the 2, or distributing the 2, plus 4. These 2x's twice. That's characteristic of squaring an expression, right? That was the 2x, and then the 2x again. So I get x squared plus 4x plus 4, and I can use the same reasoning on negative 2x plus 1 squared. I know I'm going to square the first term, 4x squared. I know I'm going to multiply them together and get negative 2x, but I'm going to do that twice, negative 4x, and I'm going to square the last term. Much faster, same result. Feel free to do it the long way, but it's good to start saving yourself some time. And I'm going to just zoom in to make my little bit of space more space and draw that to indicate what's going on here. X squared plus 4x squared is 5x squared, just combining like terms. 4x and 4x, nice, cancels. 4 and 1 is 5. 5x squared plus 5 equals 40. Why am I so excited that cancels? Because, move that 5 over, 5x squared equals 35. Divide by 5, x squared equals 7, and I can just take the square root of both sides. No need for factoring or doing the quadratic formula. And we have our answer. Says, which of the following could be the x-coordinate? We found x plus or minus root 7 could be root 7. Consider this inequality. What does an inequality do? How does notice that this absolute value, notice that absolute value. What does absolute value do? Well, it takes a value that's negative and makes it positive. Okay, so we've got on the left side, the absolute value of something. On the right side, we've got 6. So the absolute value of something is greater than 6. Which ways can that happen? Either the thing inside the absolute value can be bigger than 6, or it can be less than negative 6. So there's two possibilities. Two worlds. One where 4 minus 2x is bigger than 6. Or 4 minus 2x is less than negative 6. Either one will give us the result of that being true. So this one, fairly straightforward to solve. Add 2x to both sides, subtract 6. 4 greater than 6 plus 2x, subtract 6. Negative 2 greater than 2x, divide by 2, negative 1 greater than x. If negative 1 is bigger than x, that means x is less than negative 1. So if we look here at negative 1 and we know that x is less than negative 1, we're probably very tempted to answer C. But since we're persistent, we're going to go forward anyway and see if this confirms our suspicions. Add 2x to both sides and 6 to both sides, 10 less than 2x. Divide by 2. 5 less than x. If 5 is less than x, x has to be greater than 5. There we go. C is the answer, and it checks out. Number 14, consider the inequality. Y greater than or equal to 2x minus 1. Oh my gosh. Are you all getting tired? Let me check that this recording is actually working, because, oh my. Yep, we're recording. I sure hope I don't run out of space on my drive. I never bothered to plug my 4 terabyte drive in. If I run out of space, I'm going to be kicking myself. And you'll all be laughing. I also noticed as I talk that I should have turned my mic gain down, because I think I've been clipping when I'm exuberant. That's for later. Consider this inequality, y greater than or equal to 2x minus 1 on the coordinate plane provided in your answer space. Graph the solution set. We've been graphing lots of inequalities, so let's just do that. Negative 1, right there, that's the y-intercept. 2x, slope of 2x, okay. Which side do we want? Greater than or equal to? Everything above. So I will do that. Everything above. Having fun. I love that tool. Look at that. Isn't that cool? Okay, anyways. Should it be a dashed line? We haven't worried about that in the past problems because it hasn't mattered. But in this one, where they're actually asking us to graph the solution set, and the graph itself is part of the solution, we better do it right. It is a greater than or equal to, so we want a solid line. Write an ordered pair that's a solution to the, that is a solution of the inequality from part A. Okay, so B, a point that's in here, well, I'm going to say 0, 0. There. Because I like to be smart aleck, or whatever the word is, and save myself from having to do much work. Explain how I got the answer. Well, I looked at the graph. Maybe I'll say y-intercept, just to be nice, is negative, and 0, 0 is directly above. What else? Consider the system of inequalities. Okay. Well, let's take this system and flip it around so that we've got our solve for y. I bet they're going to ask us to graph these or do something like that. Y greater than negative x minus 2. Now I'm going to do this. This is fun. Negative y less than negative x plus 4. I want to get rid of that negative 1, so I divide by negative 1. What happens when you swap? When you divide by negative 1, you swap the relationship between the left hand and the right hand side. Right? You multiply both of those. If you multiply a negative number by a negative, it becomes positive. A positive number by a negative, it becomes negative. Your positives and your negatives switch. Everything switches around. Okay, that relationship switches around, so we represent that by writing the inequality in that direction. And we get x minus 4, so y is bigger than x minus 4. On the coordinate plane, provided in your answer space, graph the solution set. Oh, they do want us to graph it. No surprise there. C, I'm going to run out of space. No, I'm not, because D is just asking us to come up with a single point again. So let's graph this thing. Negative x minus 2. Going down. Negative x minus 2, and we want everything above. Okay, fine. And then they want y greater than x minus 4. Y greater than x minus 4. Okay. Yeah, what color should we do? Let's pick pinks and oranges. I'm getting tired of these blues and greens. X minus 4, there's minus, minus 4, lower than minus 2. There's minus 4, positive slope. And we again want everything above. So I'm going to shade everything above. And when we shade everything above, we see that the shared region is that green region. Yellow and blue makes green. That green region. And I can pick a point in there. And again, the origin works. So to have fun, we're going to say 0, 0. Right? An ordered pair that is a solution to both A and the system of inequalities from C. We got lucky that our solution from part A and our solution and that our 0, 0 solved this one and also solves this one. Pure fortune, but there's some saying about that. So put 0, 0 and we'll say we got lucky. and they'll probably won't give us full credit. So then we'll think to ourselves, well, how do I get the rest of the points in there? Sure, explain how you got your answer. The y-intercept to all three is negative. All three lines. Good enough. This equation represents an ideal gas law where T is the temperature. Oh, fun. A crazy equation with how many? 1, 2, 3, 4, 5 variables in it? That seems like too much fun. And the only one we know what it means is T? Okay, fine. They just want us to solve it for T. Okay. PV equals NR T. Let's solve it for T. Well, I don't really know what to say. We're just going to divide both sides by NR. After all that struggle, take it when they give it to you. D. And somebody write another question quick. We can't be done. We're done? Oh my gosh, I thought I had 16 more. Oh, I do, but we're not going to do those. Everybody, enjoy your weekends. Thanks for watching. Bye.